Unit testing is one of the most important fundamental practices you can implement for both code quality and development productivity. Visual Studio 2013 provides you with the ability to harness some great unit testing tooling and deliver solutions with a high level of quality and confidence. I'm Mike Vincent. In this session, we'll explore unit testing with Visual Studio 2013, implementing several tools and addressing several specific development needs. I hope you will find some great additions to your productivity tool belt. Here's our agenda. After a quick overview, we'll touch into test-driven development, then Visual Studio plugins, naming organization, what to test, data-driven test, writing testable code, testing difficult code, and database unit testing. We'll have demos throughout this. It's all about paying attention to the quality of the code we write. Visual Studio unit testing experience is focused on developers writing and running unit tests while they write their code. A unit test is an automated piece of code that invokes the method or class being tested and then checks some assumptions about the logical behavior of that method or class. A unit test is almost always written using a unit testing framework. It can be written easily and runs quickly. It's fully automated, trustworthy, readable, and maintainable. It's consistent in its results as long as production code hasn't changed. Looking at our testing categories, let's focus initially on the left-hand side of the diagram. Unit testing is the foundation for an overall test strategy to deliver code of the highest quality. Development practices are things that programmers do, which includes unit testing and integration testing, and usually embodies practices such as test-driven development. Acceptance testing, these are tests that verify when a feature is done, such as functional test, user acceptance test, testing of all of the ilities, and performance testing. Exploratory testing is testing the application without having a formal script or test case, looking for bugs or surprises. On the right-hand side of the diagram, let's focus from the foundation. Unit tests isolate and verify discrete units of logic. They're written by developers as they code the application. Integration tests are similar to unit tests but target code that is not necessarily isolated. System tests consist of multiple steps that represent realistic usage scenarios in the application as a whole. They can be automated programmatically, simulating user behavior. Historically, they are written by dedicated QA or test engineers. Acceptance tests verify that an application meets the needs of the intended users. Scope includes usability, functional correctness, and performance. A unit test validates object behaviors, states, error conditions, and assumed functionality. A unit test is independent of the system under test. The system under test is agnostic to who is exercising it. It could be an end user, it could be a tester, it could be a unit test. Unit tests test a single unit of work. A unit of work is the sum of actions that take place between the invocation of a public method in the system under test and a single noticeable end result of a test of that system. A noticeable end result can be observed without looking at the internal state of the system and only through its public APIs and behavior. An end result is any of the following. The intended public method returns a value, a function that's not void. There's a noticeable change to the state or behavior of the system before and after invocation that can be determined without interrogating a private state. There's a call out to a third-party system over which the test has no control, and that third-party system doesn't return any value, or any return value from that system is ignored. It's not a unit test if it talks to the database, communicates across a network, touches a file system, can't run in parallel with other unit tests, or you have to do special things to the environment, such as editing config files. These are integration tests. Integration tests are important too, but we're focusing here on unit tests. Be sure you understand the differences. A basic unit test is code that exercises a specific portion of your code base in a particular context. Typically, each unit test sends a specific input to a method and verifies that the method returns the expected value or takes the expected action. Unit tests prove that the code that you are testing does in fact do what you expected it to do. We use an arrange, act, and assert arrangement of our unit testing code. By following this industry convention, the code is simply presented, structured more cleanly, and it's also easier to read. In large test libraries, this makes things much more maintainable. A good unit test should be automated and repeatable. It should be easy to implement, relevant tomorrow as it is today. Anyone should be able to run it at the push of a button. It should run quickly. It should be consistent in its results. It should have full control of the system under test. It should be fully isolated, i.e. that it runs independently of all other tests. And when it fails, it should easily detect what was expected and determine how to pinpoint the problem. One of the most valuable benefits of unit tests is they give you the confidence that your code actually works as you expect it to work. Unit tests give you the confidence to do long-term development because with unit tests in place, you know your foundation code is dependable. Unit tests give you the confidence to refactor your code and make it cleaner and more efficient without breaking it. Writing your unit tests first forces you to think through your design before you write the code. It keeps you focused and facilitates better designs. You get it right the first time, increasing overall productivity and quality. Unit tests save you time because unit tests help prevent regressions from being introduced and released. The earlier that you can detect and fix bugs, the more you reduce the total cost of a project. Once a bug is found, you can write a test for it, you can fix the bug, and the bug can never make it to production because the unit tests will catch it in the future. Another advantage is that unit tests provide excellent implicit documentation because they show exactly how the code is designed to be used. And it's more enjoyable to code with unit tests. You know what your code needs to do, you make it do it, instant gratification. For the first demo, I have a simple calculator application that we'll use to demonstrate some unit tests using MS Test. First of all, let me show you the calculator. As you can see here, it's working with a text expression that goes through a parser to figure out the operations to work from. And here's a look at the expression parsing algorithm that we'll go through. As you can see, simple math operations that happen from it. Let's go ahead and hit F5 and just run this. I have to drag it over into the visible space here. And you can see it simply gives me a place to enter a text string. So let's put 5 plus 9 and see what our answer is. 14. Great. Okay. So that's how it works. Now let's take a look at the unit tests that we have. I'm starting here with the test class for unit testing. I start with a reference to the Microsoft Visual Studio.testtools.unit testing. And of course, I have a reference to the application that I'm testing, the system under test. And we'll talk about naming conventions a little bit, but you can see that I'm using this as a namespace as a project over here called C#calc.unittests. Defining my test class, and I'm getting a reference to this expression that I'm working from. And then I have several test methods to execute various tests of the math applications. I have one commented out here that I'll show you in a moment that will create a failing test. Let's go show you what the real tests look like. I'm opening the Test Explorer. And since I've run these before, we can see that they're all green here right now, but I have 11 tests. And I'm just going to say, let's run them all again. So we have our little green bar progressing up here as the tests are running. And when it's completed, we have a solid green bar and all of our tests have passed. As you can see, it tells me the time it takes to execute all these various tests, which is handy because we want unit tests to be able to execute fast. And if I see something that's going slow, perhaps I need to refactor my unit test. Let's uncomment this test here, and that will give us a failing test. And go ahead and run our Test Explorer again. And you'll see I now have 12 tests. It's running these. And in a second here, we'll see that that one fails. So here we see a failing test that bubbles to the top, and I get an explanatory message about what was going on with this. It happens that my application does not know how to handle decimal points. So therefore, when I try to do math that includes a decimal point expression, it fails because the application doesn't know how to handle it. Let's go back over to the Test Explorer and look at a few more things on its functionality. Let's say I want to run an individual test. Let's take this divide by zero test. So I can right-click on this and say Run Selected Tests. So this is going to go ahead and run. Get my result back over here, and all the other tests are grayed out. This one passed, so then I'm happy with that. Other options that I have include Run All. I can select Run Failed Tests, Not Run Tests, Run Past Tests, do the last run. And then I also have an option here to go in and do code coverage for all tests. We'll talk about code coverage in a few minutes. I can also configure playlists, so if I want to group my tests together, which will be handy when I get lots and lots of tests put together, to organize these into logical groupings that I may want to run. Test-driven development is a software development process that relies on the repetition of very short development cycles. Test-driven development is related to the test-first programming concepts of extreme programming. As stated by Kent Beck, TDD encourages simple designs and inspires confidence. The way it works is what we call red-green refactor. We write a failing test. It fails because we have nothing to test it against. We write just enough code to make this test pass, compile it, run our test, and it passes, so it's green. We then refactor that code for maintainability and coding standards, making sure that all of our tests continue to pass. And we repeat for the next requirement, and so on. But in Visual Studio, TDD works just a little bit differently. Again, we write the unit test, we compile the test, which will fail. We'll call this pre-read. We implement just enough of the target code to compile. That's the additional step that we have to do, and I'll show you how IntelliSense will help you with that in just a moment. We run the test, we see that it fails. We write just enough code to make it pass, run the test again, it's green. We refactor the code as required for maintainability and coding standards, and we're ready to repeat that for the next requirement. Now let's look and see what IntelliSense can help us with. We have to have an empty class or method for us to be able to run this, and that's what IntelliSense will help us generate. Refactoring our code. There are lots of different refactorings that we can consider. Here's just a partial list that you might want to take a look at. Refactoring, it's a deliberate activity with repeatable patterns, not just moving code around. You should refactor for coding standards and maintainability. Do it at the unit as well as at the architectural level. Use automated unit tests, continuous integration, and code coverage. Use automated regression tests. Use modern tools. Avoid gold plating, however. Refactoring should always be driven by a business need, not a bored programmer. If you find it hard to jump in immediately to TDD, start with the concept of writing code and unit tests at least in the same session while everything is most clearly in mind. A benefit of this approach is creating more testable code. Striving from TDD, you'll find that there's several benefits. You'll make smaller, more iterative code changes, which are easy to track. You'll use refactoring tools more effectively. You'll write cleaner, more maintainable code that others can understand, as well as looking at your own code 6 months from now. You'll reduce technical debt. You'll tend towards interface development. We'll talk about that a little bit more as well. You'll tend towards using design patterns and appreciate having good metrics of success. Finally, you'll appreciate having your unit tests, and as your code gets larger, it's not more difficult to maintain. Jim Newkirk, in his book Test-Driven Development, begins with a simple stack example. It has 3 functions: push, pop, and top. We need to consider cases where nothing is on the stack, when we have only a few items, and with several items. These 14 unit tests that he's provided provide us with a clear definition of what needs to be coded. For example, we need to test if the stack is empty. We need to push something onto the stack, and empty will return false. We need to pop something back off of that, and the stack should again be empty. We should push and pop content, and they should be the same items. We should push multiple elements on and pop them off and be able to compare that they are correct in the correct order. We should be able to test for invalid operations, like if the stack is empty and we try to pop something off of it, it should return an invalid operation. And we can go on and on for the remainder of the test to define what the stack looks like. And here is the result. As you can see, we have much less code in the application than we actually have in our unit test. And let's go ahead and run this test for the MS Test example and see what this all looks like. And as you can see, I've passed all 14 of my tests. Unit test frameworks are now a plug-in to Visual Studio implemented in 2012 in a full rewrite of that platform. Use the framework that's going to best suit your needs that you're used to using. We have both support for both commercial and open source frameworks. It makes unit testing a whole lot easier because you're using your favorite tool and the right tool for the job. And here's a view of the unit test architecture. As you can see, we have MS Test, Managed Code, Managed Tests, and native C++ tests built in. And then we have plugins from all the commercial and third-party sources, such as NUnit, XUnit, QUnit, and many more. Returning to our stack demo, this time we'll focus on unit testing plugins with NUnit. As you can see, I have several NUnit tests set up and configured, but let's go back to the start to implement NUnit. Let's go to Tools, Library Package Manager, Package Manager Console. This is the easiest way to add the functionality of another test framework into NuGet. As you can see here, all I have to do is type install-package and the name of the package that I want to install, which in this case is NUnit. I already have that installed, so I'm not going to duplicate my effort. As we can see, we have to install the unit test package with the solution project that we wish to work with it in. So here, as you can see, I've already got it added in here for the NUnit framework. We can also see with the Library Package Manager what I have installed, managing my NuGet packages for the solution. Once I've downloaded this to implement it with other solution projects, all I have to do is use this utility to go in and find it. We'll search on NUnit so we can bring it up. And here it is, and we can see that I have this checked off that it's already been installed for this solution. So now let's review our in-unit test fixture. The attributes are similar, but a little bit different from the MS Test attributes. Use your favorite. That's the great part about the plug-in capability. They all work extremely well, as I'll demonstrate in just a second. So we can scroll through. We have the same tests set up in in-unit that we have in MS Test. And let's go over to our Test Explorer and run those. So I have my stack fixture set up here. Let's go ahead and run the selected tests. And here we are, we've passed all 14 tests. Looks like I have a little bit of overhead getting the in-unit test framework initialized. So there you have it. With Visual Studio, the unit testing frameworks are plugins, so you can use your favorite unit testing tool. A consistent naming convention is essential for managing your unit tests. Over time, you'll likely have thousands of unit tests. You'll want to be able to quickly locate specific tests and understand what they do without having to actually open the test. Here's a suggested best practice that also works extremely well for specifying tests to be included in build automation and for excluding test code in production builds. Note, using this naming convention provides separation for both unit and integration tests. So we start with our project name, project under test, .unit tests, or .integration tests. As you can see from our example, I have content library, which is my system under test, and I have content library.unit test, content library.integration test. For my classes that are located in my project under test, create a class name with the name tests after it. So for example, I have person service tests. For each unit of work, I want to create a method that uses this convention, the unit of work underscore what you're trying to do underscore the expected result. The unit of work name refers to the method or group of methods or classes that you are testing. Don't be afraid of really long names. Make them descriptive. But please respect the use of only 2 underscores and use upper camel casing. So we can see I have unit of work, which is an example of person service. What am I trying to do? Add a valid person. Expected result. It succeeds. My second example, person service, add invalid person, throws invalid operation exception. What should I test? You should test any method that contains logic, even if it seems simple. Typically, you should test for the expected behavior, which we call the happy path, and the likely exceptions and edge conditions necessary for a robust application to gracefully handle unexpected behavior. Code that doesn't contain logic, i.e. properties, getters, and setters, doesn't need to be unit tested, although it may be used by the unit of work being tested. Also, unit testing code from other entities, i.e. Microsoft.NET Framework, third-party component, library development environment, is not productive and not needed because the code is not within your control. For black box components, if your organization controls the internal code, you should test it. If you don't control the code, i.e. .NET Framework, third-party again, don't waste your time. Test the expected happy path. This is what developers typically think of when presented with a requirement. But learn to think like a test professional. What might break? You need to write tests for the likely exceptions. Consider edge conditions. Also consider security and risk conditions that could compromise your application or its data. Unit tests are requirements, so they should be clear and testable. Well-understood requirement can be expressed as a single test or a single data-driven test or a collection of unit tests. When all the related tests pass, the requirement should have been met. This is the basis for acceptance test-driven development. Use the Right Bicep acronym as an aid to writing good unit tests. Are the results right? If the test ran correctly, how do you know? Do the tests have bugs? Test data is notoriously incorrect. Use code reviews on the tests themselves. Boundary conditions. Identifying boundary conditions is very valuable because this is where most bugs live. Hackers live for testing boundary conditions. Bogus input values, badly formatted data, duplicates in lists that shouldn't have duplicates, empty or no arguments, huge inputs. Inversion. When testing if the results are right, can you double-check by performing the inverse relationship? Cross-check. Write comparers to evaluate the state of an object and compare it to a known good. Errors. Pass in the invalid arguments because your users will. Null references, empty strings, empty lists. Use your imagination. Use the expected exception attribute to test. Performance. What happens when someone uploads a 10 megabyte file? How long does it take to execute? How long does your test take to execute? Boundary conditions. The correct acronym can help you test your boundary conditions. Does your input conform to the expected format? Is the set of values ordered or unordered as expected? Is the range within the expected range? Does the code reference anything that isn't under the control of the code itself? Does the value exist? Are there exactly enough values? Is everything happening in the right order at the right time and within time tolerances? You can configure a unit test to retrieve its values from a data source. These are called data-driven tests. The test will run successively for each row in the source. This makes it easy to test a variety of input values with corresponding output values. This is great for testing boundary conditions. Configuring data-driven unit tests. First, make the connection between the unit test method and the data source. I suggest using CSV or XML files because they're fast and easy. Conceivably, you could use a database, but that takes longer for connection and a lot more overhead. Set up this in your unit test properties. Next, assign the methods variables to retrieve their values from the appropriate column in the data source. Here we have yet another calculator example application to demonstrate the functionality of data-driven unit tests. This is a basic 4-function math calculator that uses integer values and is designed to work from the command line. Let's look at our test file. This was generated, as you see here, selecting Add, New Item, Test, and Unit Test. So here we see the basic structure of the generated unit test. You may need to add a using statement or two in here depending upon the context of your application or example. Next component that's added in here is the test context instance. And then we have the structure of the data-driven unit test itself. We start with a data source, and I'm using a CSV file. The directory of where it resides. The next statement is necessary for CSV files for reference for iterating through those. Next is the data access method, which I've specified as sequential, where we are going to deploy our CSV file to, and finally the end of the wrapper for test method. Let's look at our CSV file, and then we'll go in and look at the structure of the application. So I have 3 columns in here, val 1, 2, and 3. Val 1 and 2 are the 2 integers that I want to add together, and val 3 is the expected sum of those integers. So I'm picking these values up row by row from the CSV file, executing our add function and asserting that I'm getting val 3 equal to the sum of value 1 and 2. So that's the basic structure of our data-driven test. Data-driven tests are really great for exploring edge conditions where I can throw a range of values into a similar structure and test for the expected edge conditions. A lot of code is difficult to test. In our examples so far, we've talked about pretty simple examples with static methods. In the real world, it's never quite that easy. Doubles can help. You can think of them like stunt doubles in an action movie. They're cheaper, more versatile, less risky to work with than the real actor. Dummies are objects that are passed around but never actually used. You'll often use them to specify additional required parameters. Fakes implement the same interface as the object being represented. Fakes return responses when called by the application. Fakes may not implement all the functionality of the interface, only what the application will need for the test. Stubs are like fakes, but with instrumentation. Stubs may record information about calls. Finally, mock objects are pre-programmed with expectations. They know exactly what calls they are expecting. They throw an exception if something unexpected occurs. They are checked during verification to ensure they received all the calls they were expecting. They can return values to the application. But all code is not readily testable. In order to test code, you need to be able to isolate the unit under test from other software it may communicate with. If components are directly chained together or otherwise joined, you'll likely have an untestable condition. You can't substitute a test double that will isolate the code and reliably return a known repeatable value or response. You'll need to refactor your code for testability. Usually refactoring will help you toward more maintainable, less brittle code. As a general guideline, you'll want to make use of interface-driven programming. Take advantage of good refactoring tools. Microsoft includes refactoring tools in Visual Studio 2013. See the refactoring menu. In addition, popular commercial refactoring tools include ReSharper, CodeRush, JustCode, and Visual Assist X. There are others. To break the dependency between your code under test and a direct dependency, you can introduce one or more seams into the code. You just need to make sure that the resulting code does exactly the same thing it did before. There are two types of dependency breaking refactoring. One depends on the other. The first is extract an interface to allow replacing the underlying implementation. Then we have 4 options with fake implementations for those delegates or interfaces. Inject a stub implementation into a class under test. Inject a fake at the constructor level. Inject a fake as a property get or set. Inject a fake just before a method call. As I mentioned in the beginning, there are 3 types of end results a unit of work can have: returning a value, change the state of the system, or call a third-party object. Stubs and fakes can address testing the first 2. They are state-based. But for the last, we need interaction testing. The call to the third-party object needs a mock object double that can decide whether the unit test passes or fails. Here we have some mocking frameworks you may want to consider. Obviously, this is just a partial list. There are many more, both commercial and open source, to choose from. Mocks are useful when the real object supplies non-deterministic results, i.e. time or temperature, has states that are difficult to create or reproduce, like a network error, is slow, like potentially a database, does not yet exist or may change behavior, would have to include information and methods exclusively for testing purposes. Here is a RhinoMox example. In this case, we are concerned with the mock object that returns a specific result without regard to the parameters that are passed in. Using ignore arguments, we return a prepared value regardless of the input value. While this is a calculator example, you also might find ignore arguments useful when working with date times where now would be passed in, but for testing we always need a repeatable result. The Microsoft Fakes framework lets you isolate code for better testing. There are two flavors, stubs and shims. Stubs are concrete implementations of interfaces or abstract classes that you can pass into your system under test to isolate it from real implementations. Generated at compile time, it runs fast and uses a C# language, so there's no special API to learn, and it's type compatible ISA with the interface. Shims are generated classes and enable you to intercept and replace calls to existing classes, even those in the .NET base class library. They are sometimes the only way to test certain things. They use a profiler to detour calls. Use stubs unless you have a reason to use shims, such as when you have external components that cannot be refactored, like SharePoint, ASP.NET, Office, etc. When you need to override non-virtual methods, static methods, constructors, seal types, properties. And when you have legacy code with untestable designs. You should consider refactoring your shimmed code. Use shims to get your code under test, but don't stop there. Once you have the design and the coverage, refactor. Add new tests using stubs to verify the behavior. Keep the original test running. When you're done, you can remove the shims test. Shims allow support for times when the dependent code, for example legacy or external, cannot be changed or a detour of method calls to shim implementations is needed. In our example here, we are communicating with system.io for a log. As you can see, we've implemented system.fakes and system.io fakes in order for us to be able to come up with a repeatable implementation of our log. Through the new context menu item, Generate Inputs Outputs table in the Visual Studio Editor, you can invoke CodeDigger to analyze your code. CodeDigger computes and displays input-output pairs. CodeDigger systematically hunts for bugs, exceptions, and assertion failures. Out of the box, CodeDigger only works on public .NET code that resides in portable class libraries. If you are ready to run CodeDigger on code that doesn't sit in portable class libraries, then go to Tools Options, select PEX General, and under CodeDigger, set Disable CodeDigger Portable Class Library Restriction to True. Remember that even though you can launch CodeDigger on almost any .NET code afterwards, CodeDigger may still not be able to follow calls that leave the assembly under test. Code coverage. So how are we doing with that? I like to use code coverage as a first-class developer feedback tool. How am I doing? It's quick, it's easy, it's one button, and it shares a lot of great information with me. How much code coverage is enough? Well, low numbers tell you that you probably need more tests. High numbers, however, don't necessarily mean that you've written good tests. Just because you're fully covered doesn't mean that you're fully tested. So use the code coverage metric wisely. I really like to use code coverage as a complement with good team code reviews. And here's an example with code coverage. Some things are hard to express with a traditional unit test. Asserting an array is an example. Approval test makes this easy with a simple compare. Using the tool, it is interactive until you have what you intend. Then, that intention becomes your standard to compare against. The tool now functions in an automated mode. If a compare passes, you are green, just as with traditional unit test. If a compare fails, your favorite diff tool can expose the test and compare for you to verify. You can see what failed the test or optionally promote the test result to your new compare standard. As a best practice, write your intention in English, then go to code. You'll get cleaner, more modular code. Verify is the action verb instead of assert. For my approval test example, I'm going to use a simple array sort. But wait, I need to show you how I got here. Approval test is open source and you need to download it from NuGet. As we did earlier, we can go into Tools Options, Package Manager Console, and at the prompt over here, you want to install package approval test as I've already typed in here. I'm not going to hit enter because I've already got it installed on my machine. Once approval test is installed, you need to register it with the solution that you're going to be working with. So we'll go back over here, Tools, Library Package Manager, and we're going to manage our NuGet packages for the solution. Open this up, type approval. And as you can see here, I already have approval test and the helper class approval test utilities already installed for this solution. So in this case, I have created a separate project to demo the approval test. I've called that CoolCalc approval test. Let's open that up. And you can see in our references that I have my approval test and approval utilities already in here. Here's my code example, and you can see the using statements up here. And I've also added approval test.reporters, but we need that to be able to expose our compare tool. Approval tests run just like unit test. In this case, I'm running with Visual Studio unit testing. You can use others like NUnit if you wish. Running as my example is configured, let's go ahead and execute it. And we can see here that I'm going to go ahead and run this. And my test passes. So everything is fine with this. So we can see what that looks like. But let me make a change in this simple array sort so we can illustrate something. I'm going to take Charles over here and I'm going to rename him to Chuck. And let's go ahead and run that again. And my test failed. So when I have a failure, you'll notice that it popped up a compare tool that I have registered and gives me the arrays of what I was trying to test. Here's what I was expecting, and so I can see the differences between these two. And I have the choice over here as I can now understand what's going on, and if I want to, I can promote this change that I've made with Chuck over to the approved test, and that way we can update the test, the comparison that we are making. From the Windows Explorer, let me show you what's going on. We have generated two different test files here. One is I have the approved file, which was the one that was showing on the right here, and I have the received file that we just generated in our test, which is on the left. And if these two do not agree, approval test exposes both of these files to me in the file compare tool so that I can make my decision. Okay, in this case, I'm not going to change it. Let's just go ahead and close that test down, and then we will revert this back over here to Charles. Run the test again. And we see that now the two of them are agreeing and it passes. When I go over and actually look at the Windows Explorer, you can see that it didn't retain the received file. It only has the approved file that's persisted on the file system. Looking at the structure of my code over here, you can see instead of arrange, act, and assert, we have do and verify. Clients almost always ask me, what about database unit testing? We need to take a pragmatic look here. Integration tests are likely more realistic for your data layer, but there are opportunities and appropriate places to use unit testing. You need to consider, can you abstract away the database interfaces? Does it make sense, or is it just more work? Can you completely isolate the database logic? This may take some work, but it can return some true results for unit testing. Can you, and should you, use the real database, a copy of course? You'll be testing against real production data, but is that enough for you to fully test your edge conditions? You'll likely need to cover these edge cases with smaller and more focused data for unit and integration testing. The database unit testing framework equips you for both unit and integration testing. Run your testing in conjunction with database projects. You'll have a single source of the truth for data definition and test. Running database tests involves more work than just pure code unit tests. You'll need to cover pre-test condition, including a connection, and initiating a transaction wrapper. Post-test includes returning the database to its original state. And you may need deployment if you are fully automating your test to run in conjunction with builds. I recommend consideration of transaction scope. Let's go into a demo and see what all this looks like. This demo starts with another calculator variation that calls a SQL Server stored procedure. It gets data from an input table, performs a math operation, and stores a result in an output table. I've created a SQL Server database project that defines all the database metadata. Here's how you do it. Open SQL Server Object Explorer and drill into our database project. And here you can see I've opened up programmability, stored procedures, and I have my add stored procedure. Right-clicking on that, it gives me the option to create unit tests. I select this, and I get a wizard dialog that I populate for the information we need to get it created. Which project do I want to associate it with, and what name do I want to use? I've already created this project, so I'm not going to duplicate my efforts, but the rest of the wizard walks you through what language you want to use, C# or VB. In my case, I'm using C#, specifying my data connections, and when I say connections plural, you can use a primary connection, and you have the option for a secondary connection that you may want to use, perhaps because you have different security privileges. The designer creates the unit test with the variables that we've defined. Replace the empty conditions with the data that you want to test for. For my test conditions, I'm validating a scalar value where I expect a value of 8. Then we can look at our pre-test and post-test conditions that we can optionally set up. In addition to setting test conditions and restoring the database to its original state, you may want to do additional validation, such as checking row count in your post-test condition. Here's what our unit test project now looks like. My SQL Server information. And let's look at our actual C# unit test code. Here we can see that we're setting up our test conditions, initialize, test cleanup. We're defining our designer support code. Let's drill into that just for a moment so you can see what we have here. The actual conditions that we're working with, what we're testing for, what our expected results are. And finally, we can see our test method where we actually execute against our pretest, our test script, and execute our post-test. Now, let's go ahead and actually run our test and see what we get. The Test Explorer, I've defined a playlist with my SQL Server tests. We'll go ahead and run this, and it looks like everything passes. We're happy. Let's play with this for a moment and change a value over here. And we'll create a failing condition. I'm going to run my Test Explorer again. Run all. And we see now that we did not return the 8 that we were expected, and our test failed. So that's a quick overview on SQL Server unit testing. And finally, let's take a look at SharePoint. Unit testing and also integration testing with Microsoft SharePoint code can be extremely difficult. Ideally, you want to isolate the code being tested from the actual SharePoint framework, but SharePoint is a beast, and maintaining your own framework using mocks and fakes is hard. This is where the SharePoint emulators introduced in Visual Studio Ultimate 2012 come into play. The emulators provide a set of libraries that can be used to create isolated unit tests for Microsoft SharePoint 2010 applications using Visual Studio 2013 Ultimate. The SharePoint ABI is rather large. As such, Microsoft focused on only emulating the types and methods that are used the most. If you attempt to call a method that has not been implemented, your test will fail with an unimplemented exception. If this occurs, you'll need to provide your own shim code to implement that method. You can also implement your own custom shims to customize the emulators to provide specific results for your environment. When you're ready for your unit test to run against a real SharePoint environment, as opposed to the emulators, all you do is change the emulation scope from emulation mode.enabled to an emulation mode.passthrough. You can also use things such as data-driven unit test initialization code, or preprocessor directives to automate which emulation mode to use. Finally, build is where you harness automation. I recommend that you include running your whole suite of unit tests with continuous integration builds, as well as providing the foundation for regression testing and nightly and other builds. I'll have more detail in my build, deploy, and test session on WinElect Now. To recap, we've taken a look at these areas of unit testing. As a developer writing code, unit tests should be an essential part of your development routine. Here's a good checklist for you as we wrap up. It includes checks on descriptive naming convention, documenting your code, descriptive error and assert messages, adopting an interface-driven design, keeping it simple, keeping it focused, having one logical assert, organizing and maintaining your test, and testing the good, bad, and the edge cases. Finally, treat your test code as a first-class citizen. Refactor as vigorously as your application code. Do code reviews of your tests. Use source control. Maximize automation and repeatability. It will serve you well. I'm Mike Vincent. Thanks for watching.